Hello everybody, hope everybody's having a good day today. Today I'm just going to be going over a question, a LeetCode question, find median from data stream. It's a hard question, but don't worry too much. It's relatively easy once you split it up and kind of understand it. So really the purpose of this is to find the median, and for those who are not completely familiar, median is the middle value within a data stream, or within any data, different than the mean value, which would be the sort of more add them all up, divide by the total number of numbers. So that's what we're doing today. Real world examples or applications of something like this might be to adequately, view trends within data and making or potentially averages within data, without having it be skewed by anomalies on one side or another. So, for example, if any of you know anybody who has worn a heart Holter monitor before, which is it's like a little thing that goes on your chest. You wear it for 48 hours. It monitors your heart rate. If you think about it, 48 hours, you're getting your heart rate monitored. But maybe one of those hours, like let's say it's Monday, you go to the gym on Monday, and your heart rate goes to like on average 150 beats per minute for 40 minutes. That's gonna skew the average if you were to do means. So you might want to be able to find the median as the data is coming in. I mean, other applications as well could be like social network analysis for engagement scores, making sure that you're getting a true depiction of that engagement score. But anyways, so that's what we're doing today. And so we have to have two components to this question. The median finder, which is going to return the median, and another function which is add number, which, or sorry, median down here, find median down here, add number, which is going to add to the data stream. If we have an odd number in the array, we want to return the middle value. But if we have an even number, there is no middle value, so we have to take the two values that are most central, most middle, add them up. 2 plus 3 divided by 2 is equal to 2.5. And so yeah, so I've basically already implemented it all here, but I wanted to give an explanation for everybody who might be struggling with this question. So here's our add num, here's our find median. So find median does exactly what it says. It finds the median. This part is for seeing if it's even, and this part is seeing if it's odd. And then this is just some logic about where it adds to the structures. So anyways, how roughly do we go about creating a data structure that is going to suit our needs, that's going to do what we need? So one way you can do it was with an abstract data structure called a priority queue, which just maintains a priority between parent and children elements. And I've got a picture here which kind of shows it. So if you think about our question, let's say this was our data stream and this is the state at which it is currently. We have a middle, but there is no middle in this case because this is an even integer list. And what we want is either the middle or the two most middle values. But we know if we're getting the two most middle values that the one on the left is going to be the maximum of the left side, and the one on the right, the middle value on the right of what the middle would be the minimum of the right side. So that's where the priority queue, which can be implemented in different ways, implements a min and a max heap. So for the max heap, this is the same thing. So 7, 6, 5, 7, 6, 5, 4, 3, 2, 1. And the heap property of min and max heaps only maintains that the parent elements are supposed to be larger than the children elements, or the parent elements are supposed to be larger or smaller than the children elements. But left to right doesn't matter so much. So anyways, if we implement this problem or use this data structure, the min and max heaps, to solve our problem, we are able to maintain the two most middle values. And so yeah, that's what we do. And just so you're aware, I've written it down as two different arrays down here. So these are like first level, second level, third level. And to go, let's say, I'll just show you these functions here because they're a little important, I guess. To go from like a parent to a left child, like let's say this is the 0th index, this is the first index, this is the second index. If you notice, every single level has 2 times as many elements as, like the subsequent level has 2 times as many elements as its parent, so 1, 2, and then 4. So to go from like this to here, so that'd be the right child, you'd go 2 times the 0th index plus 2. So that would be 0 plus 2. Then we go for, like, you know, there's one index, there's the second index. If you wanted to go from 5 to, let's say it's left child, well, parent to left child is, this is 0, 1, 2. So 2 times the index, which is 2, plus 1, which gets us to the 5th index. So 0, 1, 2, 3, 4, 5, and that's there. And you can see that too, like, I mean, the same thing works here. So that's how you traverse. And going the other way is you minus the index by 1 and you divide by 2. And in the code, we do a math.floor. But anyways, roughly speaking, I'll do another video on the priority queue, which is its own sort of thing. It's just got a bunch of functions here. OnQueue adds to the array. DQ removes from the array and also returns the apex, which is like the front, so either minimum or maximum. Front just returns the front, and size gives you the length, and is empty checks if it's empty. Heapify up, heapify down, these maintain the heap property, which is either that children are smaller than their parents or children are larger than their parents, and swap is just kind of a helper to swap the two elements. So if you were like, if you were comparing and it was the condition was not met, which is the compare function, and again this requires a little bit more detail, but you'd swap them until the heap property is maintained. So basically, if we look at this, I think this function here, find median, makes a little bit of sense. This is like if they're equal in size, so greater half is going to be our greater numbers, so the right side is going to be here because they're greater in number, and the lesser half is going to be our lesser numbers, which is here, right? So if the two halves, or if the two arrays are equal in size, then you know it's even, so you're going to divide by 2. And if not, we're going to keep the median in the, we're going to keep the lesser half a little bit bigger so that we can always have the front. And keeping that in mind about keeping the lesser half a little bit bigger, we do something with that in here. Here is the add number, so add number just gives logic as to which array to add to, lesser half or greater half. And if lesser half is empty, so it's 0, or if the number is lesser than the front of the lesser half, we're going to add to the lesser half. So if it's empty, or if like the number's really small, you know it's going to go in the small half. And then if not, you're going to add to the greater half. And then there is some balancing stuff here, because again, we want to maintain, if it's odd, we want to maintain that the lesser half has a little bit more, has more numbers in it than the greater half. So then we can just pull from it here, right? So if first statement is if the lesser half is growing too much in size, like if lesser half minus greater half is equal to 2, meaning that lesser half has got 2 more elements in it than the greater half, then we're going to add to the greater half what is taken out of the lesser half. Okay, so that's generally what you're doing. If the greater half is greater in size than the lesser half, then we're going to take from the, or we're going to add to the lesser half and take from the greater, what is taken from the greater half. So that's going to maintain that either we're going to always have, like if it's like this, so this is okay, we would take this to find the median. But then if let's say another number comes in, we add a number, and it's less than the lesser half dot front, like let's say it's 1, we would add here, right? So we'd put 1 in this line here, and then there you go. But then down here, it would take lesser half minus greater half, and if that's equal to 2, which in this case it would be, it's going to take off from the lesser half, sorry, over here, which pops the element, and then once the element's popped, it does that heapify thing where it maintains the heap property, and it's going to put it into the greater half. So it's going to go like this, and then this is going to be like this. So yeah, it's like kind of like a high level overview of how this works. Might not be the most clear, but I think it gets the point across a little bit, and in another video I'll go over this. Most people don't even implement their own priority queue, but I figured it was kind of a good concept to understand. So I put together a little, this is the same code but just with logging in it. So I'm just going to clear this and run this. So you can kind of see in action what's actually happening here. So I'm going to scroll up. So this adds numbers 0 or 1 through 10 in random, should be random order. Yeah. So how it works is if we add 5, 5 is going to be the lesser half so far, state so far, is going to be 0. So we're going to add it there. So adding to lesser half, because 5 is less than lesser half's front, or lesser half is empty, so you add to lesser half. And then there's no balancing going on because lesser half is not greater by 2, and greater half is not greater by 2 than greater half, and greater half is not greater than, at all than lesser half. So then you add 4, and then it's going to say, okay, well, here's our state so far. Lesser half is 5, greater half is empty. So with that, we're going to add to lesser half because added num 4 is less than lesser half's front, which is actually the case because this is our front, or lesser half is empty, but it's not the case. But now, because lesser half is greater than greater half by 2, we're going to balance, and we're going to move from the lesser half to the greater half. So we're going to take the apex, which is really kind of happening, I'll show you here. So yeah, you take it here, you return it, and then that's what you're going to add into on queue here. But again, that's a video for another day. But anyways, we're going to take from the lesser half, we're going to add to the greater half, which is going to come, and it's going to, now it's going to be balanced. So because it's even now, you're going to take the two most middle values, which technically are these two, you're going to add them up, you're going to divide it by 2, which gets you your median after adding 4, which is 4.5. Then if you add 6, that's, if you guys know, should add to the greater half because it's larger than lesser half's front, so it goes there. But now, because greater half, because again, when it's odd, we want to keep the median in the lesser half. So we're going to balance because greater half is bigger than by 1 than the lesser half. And so it's going to take from the greater half and it's going to put it in the lesser half. So it's going to take the front, which is its minimum value, right? Like, I mean, that's our minimum value because the greater half is a min heap. And it's going to add to the lesser half. And now, if you guys know, the median should be 5 because we keep the median when it's odd in the lesser half, so that's 5. And then if you add 7, well, 7 is going to go into the greater half because it's not less than the front of lesser half. And so now we're balanced. And again, both of the fronts are the zeroth index. Zeroth indexes are always the top. So they're going to be these two numbers, whatever these two numbers are, closest to the middle. And when it's even, you're going to add them up. 5 plus 6 is 11, divided by 2 is 5.5, and then it just keeps going. So 1 will go into lesser half, see how it comes down here, and then now our median is just here, because it's odd, so it's going to be 5. Then we're going to add 8. 8's should go into the greater half, it does, and then we have an even sides of both arrays, so we take 5 and 6, we add them up, which is 11, 5.5. So you see how this can happen, but you can also understand that, let's say we added like 111 here, right? Like instead of, or let's say we added 800 as opposed to 8. It would it would add to the greater half, but it wouldn't make the returned median, it wouldn't skew it. Versus if you think about if we added 800 and we were just adding them all up and dividing by a number, the total number, 800 would skew it, right? So that's where median kind of comes in handy. But anyways, that's just a brief explanation of what has gone on here, and I hope it kind of clears it up for anybody that conceptually wasn't completely understanding this, what its role is, why maybe it would be important to learn, and yeah, I mean the code's right here, take a look at it, and other than that, everybody else have a great day.